So good day viewers, welcome to my YouTube channel. Right here with me I've got a question for 2023 mathematics paper 2 for internal candidates. This is a question that is coming from the topic called trigonometry. So this is the question that we have been given. We have the side PQ, we also have the side PR, then we have the angle PQR, meaning the angle at Q is what? 105. Calculate angle QPR. So meaning that they want us to find an angle which is going to be at what? At P. So here we need to know which formula we are going to use. So this is a non-right angle triangle. So the two possible formulas that we can use, we can apply the sine rule and the cosine what? The cosine rule. Now study your triangle carefully. So they want you to find this angle QPR, the angle at P right here. So to find this angle, you know that you need the side this side, okay? Because I have two sides, okay? So sine rule states that we can use sine rule if we are given two sides. We have this side and this side. And any included angle, we have this included angle. We can use sine rule. Apart from that, we can also use sine rule when two angles and a side are given. So when two angles are given and a side. So in this case, when you look at what we have two sides and this angle right here. Okay. Then we also have an included angle which will be right here. So this an included angle is the one that is reflecting to this side. So let us identify our sides. So we have this side R, which is representing an angle. Then this side where is corresponding, we're going to have small letter R. We have Q here, we are going to have small letter Q. We have P here, we have small letter what? P. Now, in order for us to find an angle at P, we need first to find an angle at R. Because at R we have the side, then at Q we also have the side and the angle which is right here and the side. Okay, so when we find the angle at R, this angle now will help us to be able to find the angle at what? At P. Okay, right. So to find an angle at R now, we are going to use the sine rule, because here I've got an unincluded angle which I want to find. Then I've got the corresponding side. I also have this angle right here. Then I've got a side. So meaning two sides have been given, okay? And an unincluded angle which I want to find, so that it helps me to find the angle at P. So we know what the sine rule is, okay? So we are going to say R over sine R is equal to, so we have Q over sine Q. So make sure you take what you have been given. So this R is the side which is right here. Then this sine R presenting an angle at R right here. This Q is the side that we have the small letter Q right here. Then sine Q presenting an angle at what? At Q. So from here we are just going to substitute. Where there is R, we are going to put 41.6, okay, over sine R. So when we write sine R, we just write it the way it is because we don't have an angle at R, equal to, where there is Q, we are going to put the side for small letter Q, which is a 70, okay, over sine. Now this Q is an angle at Q which is right here, a 105. So over sine 105 degrees. So I want to find now this angle right here. So this is a fraction, this is also a fraction. We need to cross multiply. So sine R times 70, we are going to have sine R times 70, which is equal to 41.6 times sine 105. Okay, so when we punch this on the calculator, 41.6 times sine 105, it's going to give us 40.6 0.182 514 37 363. So this is the value that we are going to all right, so this is the correct value that we are going to get. So our main interest is in finding this sin error. So we need to get rid of this 70 right here by dividing throughout by 70. Even this side we divide by 7, so that this 70 and this 70 will cancel. So when it cancels, we are just going to remain with sin error is equal to, so 40.18251 divided by 70. So the moment we divide, we are going to get 0.57403591962. So when you punch this, you divide, you get this value right here. So since we want to find the sin error, meaning the angle at error, we need to get rid of this sign, okay? So we're going to say angle error equal to, so to get rid of the sign, this is where we are going to have sine inverse of this value, which is 0.57403591962. So you just need to press on your calculator, you find the value of sine inverse of this value, okay? So when you press, we are going to have sine angle error is equal to, when you press on the calculator, sine inverse of this, it will give us something like this, 35.0321497,932. So make sure that you are also punching on your calculator so that we come up with same values. So therefore, angle error is equal to, so remember what the rule says. If the degree of accuracy is not specified in the question, leave your answer correct to 3 significant figures. So for angles, just 1 decimal place. So we have 35.0 degrees, okay? So in short, just the same as 35 degrees. So the angle now at error was a 35. Alright, so we have found that the angle which is at error right here is a 35 degrees. Now, they wanted us to calculate angle QPR, meaning an angle at P right here. So if you have two angles inside the triangle, it's very easy to find the other angle, because we are just going to apply the principle of what? The sum of the total angles in a triangle, they add up to 180. If you add this angle plus this angle plus this angle, should give us what? 180. So to find the angle at P, we are going to use that principle, where we are going to say angle P is equal to, so the total is 180 degrees, that is the sum of the angles inside the triangle, minus, so we need to add this angle plus this angle, then we subtract from 180, okay? The remaining value that we are going to get, that is the angle which will be at P. So right here, we know that we have 105. So 105 plus 35, okay? So we are going to have angle P equal to 180 minus 105 plus 35. This will be 140 degrees. So therefore, angle P is equal to 180 degrees minus 140 degrees. This will give us a 40 degrees, meaning that the angle now, which was right here at P, was a 40 degrees. So we have found our question 1, okay? We have found our question 1. I hope it's clear. Let us now move on to question 2. Alright, so we've now come to question 2. Question 2 says, calculate the area of triangle PQR, the area of triangle PQR. So to find the area of this triangle, since we have the two given sides, this side and this side, so the moment we use this side and this side, we are going to use this angle right here. It's the included angle, okay? the one that we found. Now, you can also use this angle right here, but if you use this angle 105, you need to use it with the side which will be right here. Okay, that will require you now to find this side using this angle, which will be it's a long process. Okay, so just use this side and this angle. So we are going to say area is equal to 1/2 times. So since I'm using this side and this side, so we said this side is small letter q, then this side is small letter what? R. So we are going to say QR. I'll use this q and this r, the sides, then times sine. We are using this angle at P. So we are going to say sine what? Sine P. So I hope you have gotten what I've said. So from here, let us just substitute where we say area, okay? Area is equal to 1/2 times Q, this is the side which is 70, times R 41.6, then times sine, okay? Sine 40 degrees, meaning sine P, the angle at P right here, it's a 40 degrees. So from here, no need to stress too much. I'm just going to say area equal to, we can just punch everything on the calculator. We're going to get 935.8987. So make sure that you also have a calculator that you are using so that we get the same values. So this is the value that I'm getting. So from here, I need to leave my answer correct to 3 significant figures. So therefore, area equal to 1, 2, 3. So I'll write 9, 3. Now this 5 will be rounded off by this 8 because it's greater than what? 5. So this will be a 6. Okay, what units are we using? Meters square. So this is our area. So area is equal to 936 square meters. So remember what I've said? To find this area, okay, we have used this side and this angle at P. You can also use this angle 105, but to use this angle 105, you need a side here and this side a side. And to find this side, you're also going to use sine rule using this angle, which will be a long process. So hence, I've used this and this plus this angle. All right. So we have answered our question 2. We got to our question 3. All right. So we've now come to Roman numeral 3. Calculate the shortest distance from point Q to point PR. Okay. So let's see what they are talking about on the diagram. Alright, so this is the diagram that you have. So they want you to find the shortest distance coming from point Q until you reach point PR on this line PR. Okay, so they are talking about coming all the way from this point, then you come and reach this side, okay, along this distance PR. So how can we find this shortest distance? Okay, how can we find this shortest distance? So to find the shortest distance, we are just going to use a very simple formula. Okay, we are going to use a very simple formula because this is from the point Q along the line PR. So to find this shortest distance, we are going to say, so we will use our formula where we say shortest distance is equal to, we'll get 2 times the area, okay? 2 times the area divided by the distance of what? Remember, it's the shortest distance from Q to PR. So you get the 2 times the area and then you divide it by the distance of PR, okay? You divide it by the distance of what? PR, along the line where the shortest distance is touching. So this formula is just coming from the area of a triangle. Remember, I've cut the I've cut the shape. Okay. All right. So I was saying, remember I've cut the shape. Okay. The shape has been cut from this point Q coming to this line PR. Okay. So how do you find this shortest distance? Because this is a triangle, so just consider the area of the triangle, which is area is equal to half times BH. Okay, so in short, we just made height as the subject of the formula for this one. Okay, that's why I'm coming up with that formula. So on the formula, I've said 2 times area. You need to know your area. It's the value that we found, which was the 936. Then the distance PR is this 70. So we're just going to fuse in our formula. This is our data right here. Our area is equal to this 936. Our PR, the distance of PR is 70. So the shortest distance is equal to 2 times, where there is this area, we'll put 900 and what? 36 divided by the distance of PR, which is a what? A 70. So from here, you can say shortest distance is equal to, when we multiply 2 times 936, we are going to get 1872 divided by 70. So from this stage now, we are just going to divide. So shortest distance is equal to 1872 divided by 70. This will give us 26.74 285, okay, 714286. So we need to leave our answer correct to 3 significant figures. Therefore, the shortest distance will be 26 point. So this 7 makes it 3 significant figures. So it has to be rounded up or down by the next number. So this next number is a 4, less than 5 going above. So it can't round up 7 to be just 7. Okay, the units are meters. So this is the shortest what distance, which is 26.7 meters. So we are done answering our question A. Okay, we now move on to our question B. Guys, we now come to our question B. Question B reads, solve the equation tan theta is equal to 2.75 for 180 degrees less than or equal to theta less than or equal to 270 degrees. So this is the range, very important. So for this tan theta, they want you to find the values of theta which should lie along this what? This range. So first thing, we are going to write tan theta, which is equal to 2.75. This is what we have been given. So from this stage, we are going to say tan, this theta, will replace it with the basic angle alpha, is equal to 2.75. So we need to find the value of this basic angle. When we find this value of basic angle, it will help us to find the value of the theta. So from here, we are going to say alpha equal to, so this tan, it will become tan inverse of 2.75. So alpha is equal to, when you press on the calculator shift tan inverse of 2.75, it's giving us 70.01689 34781. So remember, we need to leave this answer because alpha is representing an angle. Alpha is equal to 70.0 degrees, which is just the same as alpha is equal to 70 degrees, because this 0 can't be rounded up by 1. Okay, so it will be just 0. Now we can also leave it as just 70 degrees. So we know the value of alpha. So if we know the value of alpha, we now need to know the value of theta. So when you look at the quadrants, okay, when you look at the quadrants, we have 4 quadrants. Okay, so we say in the first quadrant here, in the first quadrant, all angles are positive. Then in the second quadrant right here, in the second quadrant, only sine is positive. Then in the third quadrant, only tan is positive. Then in the fourth quadrant, only cos is positive. So having this knowledge now, when we go back to what we had, it was tan theta is equal to 2.75. This is already a positive value, meaning that tan is positive. Okay, so since tan is positive, this tells us that in the first quadrant it qualifies because all angles are positive. So the value of theta in the first quadrant, we have said, is going to be 70 degrees. Okay, then where else is tan positive? It's in the third quadrant. And in the third quadrant, if you find an angle of tan in the third quadrant, we are going to say Q3 representing third quadrant is equal to, where we say 180 degrees plus the basic angle. So this tells us that theta is equal to 180 degrees plus the basic angle. I found that it's a 70 degrees. So theta is equal to, when we add 180 degrees plus 70 degrees, this is going to give us 250 degrees. So this is the value of theta in the third quadrant. Now, before we make up a statement, we need to look at the range. Okay, the range is very, very important. So we need to consider the range. What was the range? So according to the question, the range is 180 degrees less than or equal to theta less than or equal to 270 degrees. Meaning that if you get an angle which is below this 180, you should not consider it because the range is starting from 180. So in the first quadrant, the angle is 70. So this angle should not be included. So I'm just going to say, therefore, theta is equal to 250 degrees because this angle is lying along this this range. Okay, so we have answered this question. We now move on to the last question. All right, guys, so this is our last question. Simplify 3d squared minus 27 over d plus 3. So to simplify this question, first we are going to rewrite the question, which is 3d squared minus 27 divided by d plus 3. So from this stage, we are going to consider the numerator. We have 3d squared minus 27. So in terms of the letters, we only have d. In terms of the numbers, we have 3 and 27. We need to find the highest common factor of 3 and 27, which is a 3. So we factor out 3, open bracket, 3 into 3d squared. This 3 and this 3 will cancel, remain with the d squared, minus 3 into 27, it's a 9, we cross, over d plus 3. So from this stage now, the moment you have seen d squared minus 9, and this 9 is a perfect square. Okay, so this means you can write something like this. You can write right, so we are going to write 3 open bracket d squared minus, so since this d is squared, this 9 is a perfect square, we are going to write it in index form. We write 3 to the power 2 because we know that 3 to the power 2 is the same as what? 9 over d plus 3. So the reason we are writing this, because we have seen the squares and there is a minus. This tells us that we are dealing with a difference of what? 2 squares. So we are going to write 3 open bracket d minus 3 close bracket, then d plus 3. Okay, over d plus 3. So you can see that we have some terms that are common, this d plus 3 and d plus 3, which will give us here a 1, here a 1. So we remain with this term, which is 3 open bracket d minus 3. Okay, so this is our final answer. So thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. So please don't forget to subscribe to my YouTube channel to get more content like this. Bye-bye.